Hi everyone, Mr. Roloff here, and today we're going to talk a little bit about the molar mass of compounds. Now, what you should have already watched and you should be proficient in, you should understand how to know the molar mass of just regular elements. So if you haven't watched that introduction to the mole video, I'm going to stop you right here. You should probably go back and check that out, because if you have no idea what the mole is at this point, we're going to assume that you know a few things coming into this video. So you should understand that 1 mole can mean two things. It can mean that 6.02 times 10 to the 23rd if we're counting something, kind of like a dozen is 12. And then in the chemistry, that is going to have a certain weight to it. And so we could also find how much a mole of something will weigh. So those are kind of our two avenues that we're going to go down. So now that you know how to convert elements and atoms, how would we convert compounds? So our question that we want to solve here is, if you have 25 grams of H2O, how many molecules are there? Well, if this were just, say, hydrogen, you would already know how to do this. 25 grams of hydrogen, how many atoms are there? You go grams to moles, and then from moles you could go to atoms. But how does that work when we have a compound, H2O, as opposed to an element? Well, the first thing we need to know is, where would I find the molar mass of the compound? It's not like I can look on the table and there's not an H2O element up there, right? So all we're going to do is we're going to look up, okay, it looks like I've got 1 hydrogen here. So if I have 1 hydrogen, 1 mole of hydrogen weighs 1 gram. 1 nitrogen, 14 grams. 3 oxygens are going to, each one weighs 16 grams, so 3 times 16 gives us that 48. And then all we have to do is add them up. So it's that simple. All we're doing is just adding up those different molar masses. So let's actually go back to our problem here, 25 grams of H2O. Well, with dimensional analysis, remember, step number 1, write what you know. So the first thing we should do is we should write that 25 grams of H2O, and we should put that as our starting point. Create a T-chart. On the bottom, try to take a guess. What would go down here? So we need grams of H2O. So our next step is to at least know, I would fill in this one right here, because we know that that unit has to be grams of H2O. Well, what number do I put with that? Well, 1 mole of H2O weighs how much? Well, that's kind of what we did on the last slide. We'd add up 2 hydrogens. So 2 hydrogens is, each one is 1 gram, so 1 times 2 is 2 grams, and if I have the molar mass of oxygen is 16, and I only have 1 of those, so that would be 16 grams, so my total mass is 18 grams. So, we don't need to see any work, but a lot of times what I'll see on papers when students are doing this is you just see maybe a little, like, that's a 2, and that's 16, so we add those together, that's 18. And then all of a sudden I'll know that you did it right, or that you know what it is, because your answer will be correct down here. So 18 grams of H2O in 1 mole. And that's really the only thing that's new. Because if I'm trying to now go to molecules, well, I've got, if I cancel these out, I have moles left over. I don't want moles. I want molecules. Even though they sound the same, they're not. Remember, a mole is 6.02 times 10 to the 23rd or something. A molecule is when we take atoms and put them together. So how many molecules are there? It's the same thing as saying how many atoms are there. So we know that 1 mole is going to go on the bottom, because, again, we want these units to cancel. What goes on top? You might have guessed it. 1 mole is how many? 6.02 times 10 to the 23rd. And you might say, well, wait a minute. I thought that this had to be atoms. No, remember what a mole is. 6.02 times 10 to the 23rd of something. It's a way of counting. So just like I could have a dozen eggs, it doesn't mean I can't have a dozen bowling balls, right? Or a dozen feathers, or a dozen paper clips. I can have a mole of whatever I want. So in this case, it's not atoms, it is molecules. So that's really the only change with that. Remember, calculating this, what we're going to do is we're going to multiply anything that's above this line. So we'll multiply our 25 times 1, divide by 18, times 6.02 times 10 to the 23rd, divide by 1, hit equals. Our answer for that would be 8.4 times 10 to the 23rd. And the unit, what are we left with? Look at what's not crossed out. Molecules. I'm just going to put MC of H2O. So this next portion of the notes is really going to be helpful for you when you are working on the homework assignment. So let's just take a look at it. If we have one molecule of CH4, it's going to contain, and I could even draw one out here, C, and then I've got 4 H's around here. I've got 1 carbon, and I've got 4 hydrogens, right? So if I were to, duplicate this, and I don't know of a good way to do that, but imagine now I've got a dozen of these. Now I have 12 of those pictures. Well, it probably makes sense that I have 1 dozen carbons, and I have 4 dozen atoms of hydrogen. Imagine now I have a mole. You can probably fill this in pretty quickly. So the key idea here is that it's all kind of related, I guess you might say. So for that first section of the notes, it's just asking you to make sure you understand that no matter whether we say molecules and atoms, dozens or moles, those numbers don't really change. So it's all kind of relative, if you will. One thing that I think I'll add in here that I just want you to think about as well is, what if it's not 1 mole, what if we have 2 moles of CH4? Well, now we have 2 moles of carbon, and we have 8 moles of hydrogen. So you'd multiply those numbers from your original formula by how many moles you have. So this will be that little section would be helpful with the bottom part of the homework sheet. So next we get into molar mass. So we're gonna need a periodic table for this. Our molar mass of CH4, just like we practiced adding these up, 1 carbon is going to be 12 grams, and for each hydrogen is going to weigh 4 grams. Each hydrogen weighs 1 gram, but there's 4 of them, so the total molar mass for the hydrogens is 4 grams. So our total is going to 1 mole of CH4, then 12 plus 4 gives us that 16 grams. Now what if we double that? Just like you saw on the previous slide, if I double that number of moles that I have, I also have to double the mass, so 16 becomes 32. What if I have 0.1 moles? If I have 0.1 moles, well, now instead of 12 grams for my carbon, that 12 grams times 0.1 gives me 1.2. And for my hydrogen, instead of 4 grams, now I times 0.1, that gives me 0.4. So my total, when I add those together, would be 1.6. So what if I give you 64 grams of CH4? How many moles is that? Well, 64 grams, and you could even set this up almost like a T-chart, right? 64 grams, if 1 mole of the CH4 is 16 grams, it looks like there are 4 moles of CH4. So hopefully that helps. Obviously, please talk to your instructor if you have any further questions.